Hello everyone, Mr. Newman here, and real quick we're going to learn about functions and graphs dealing with piecewise functions. So first thing you need to know is that a piecewise function, the way it works is you have two or more functions rolled into one function. And the way that works is, for example, you have y equals x plus 2 if the domain, if x is less than or equal to 1. And then you might have another function like y equals 4 if your domain is in x greater than 1. So let me show you how that works. First of all, we've got this, this input of 0 for part A right here, okay? And we're going to look at, all right, does 0, is it greater than or equal to 1, or is it greater than 1? And sure enough, yep, 0 is less than or equal to 1. I think I might have said greater than. 0 is less than or equal to 1, so therefore 0 is going to be plugged into x plus 2. All right. Right here we've got x plus 2, but instead of x, I'm going to plug in my input 0, and 0 plus 2 is 2. Next up, now that top part was just to visualize. If you don't need to copy that down each time, but that was just for you to visualize how we figure out which function we use when the input's a certain number. So I'm going to keep erasing and reusing that top one. For example, right here for the number 2, an input of 2, is that less than or equal to 1, or is it greater than 1? Well, the number 2 is greater than 1, so we're going to use the function 4, or y equals 4. Now this is a little bit bizarre because there's no x to plug in anything, so we're just going to write down 4. We don't need to use the 2, and that's often a mistake students use. They say, oh, I have f of 2, I need to put the 2 somewhere. Well, there's no x, so we don't need to put the 2 anywhere because there's no place to substitute the 2 in, okay? All right, the last one is the number 1 because of the input of 1 here. And what we're going to do is say, all right, is 1 less than or equal to 1, or is it greater than 1? And because of the or equal to, it is less than or equal to 1. So we're going to use the function x plus 2. So we plug in 1 into x plus 2. So it's 1 plus 2, which is 3. Now, in order to graph it, there's a few different ways you can do this. One way that takes a lot of time is just to make a table of values and you use the values you got, which this is not a bad way to do it. If you understand the input and the output, for example, the input, when we plugged in 0, we got 2. When we plugged in a 2, we got out 4. When you plugged in 1, you got out 3. And that's a great way. You can plot those points and get a feel for what the function should look like and hopefully fill in the holes. But a better way to graph these, better I say because it's faster, is what I'm about to show you right here. You need to identify where does the function change over, okay? So this function, you see how we're talking about x is less than 1 or x is greater than 1? That means that the function changes from one part of the function to the other part at x equals 1. So I'm going to go ahead and draw a vertical line at x equals 1, or maybe a little dashed line because it's not actually a part of the function. Next up is I'm going to plot, though, and I went ahead and graphed 1, 3 because that's on the line. That's often helpful. I'm going to go ahead and graph y equals x plus 2. I'm graphing x plus 2 because that's the first function. But I'm only going to graph it for when x is less than or equal to 1. So only include the points where x is less than or equal to 1. Now that has a y-intercept of 2 and a slope of 1, so it's going to look something like this. Let me go ahead and draw the line, and it's very important that we make that dot right there, 1, 3, a filled in line because of the x is less than or equal to, okay? All right. Now for the right side, we're going to graph y equals 4 because that's where x is greater than 1 on the right side of that dashed line. And to graph y equals 4, that's just a horizontal line at 4. So I'm going to draw my horizontal line, but I'm going to slow down as I get closer and closer to x equals 1 because the function does not actually exist at x equals 1, okay? The function, because it doesn't exist, we actually need to use an open circle. So the open circle means it does not exist there, but it gets infinitely close. So if you were to plug in, if your input was 1.1 or 1.01, numbers that are really close to 1, it actually does include, it just doesn't include exactly 1. So notice how we have the open circle and the closed circle there in the middle, and this is exactly how you graph this piecewise function. So let's look at the next one, and I'll let you guys graph the next one. First of all, the input is 0. So we're going to look, all right, are we going to use 3 or are we going to use x minus 2? Well, is 0 less than or equal to -1, or is it greater than -1? And 0 is greater than -1, so we're going to use x minus 2. For x minus 2, we're going to plug in 0 for x, and we get -2. I went ahead and did the first one. I want you guys to do the next two. Try those two right there, plugging into that same function g of x. And then I want you to try to graph it. Now, I'll give you a hint. Your dashed line where the changeover of functions happens should be at -1. So be very careful when you meet in class. You're going to talk about, hey, where did you make this open circle and the closed circle, okay? And then go ahead and try the last one. Oh, another hint I'll give you is that the y equals 3 is on the left side because that's x is less than -1. And the y equals x minus 2 is on the right side because that's for x is strictly greater than -1. So go ahead and try this, try those, and try this last one as well. The last thing I'll tell you is a hint is to make a table of values if you get stuck, especially with this quadratic here, because we haven't really talked about that, but I know that you guys can square numbers. So I think if you make a table of values, especially for that side, you'll be able to figure out what's going on over there. All right, thank you for watching.